All right. Thank you everyone for coming. And I brought you a very interesting topic which is quite hot in the industry at the moment, which is Copilot. And I'm going to take you through the steps of building the Copilot. But before that, I will do some intro, some about the AI, evolution of OpenAI, stuff like that. So before I start, oh, yep. Brief intro of myself. I confuse people with my name. It's actually written the other way around. Actual name is Irfan, but documentation is Muhammad Irfan. So I don't mind people call me Irfan or Muhammad, but actually it's Irfan. I'm senior cloud solution architect working at Microsoft for about 2 years now. Started my career as a software developer about 25 years ago. So I'm not that old, but it's like I just started my first coding in assembly in C, and I wrote my first game in C, then C++, Java, and then latest technologies. A bunch of certifications I already have, plus these are the some, which plus I have more. My LinkedIn QR code, if you want to connect, you can. Cool. So let's talk about what we're going to discuss today. As I said, we're going to start with the journey of AI. Then we're going to talk about Azure OpenAI, what it is, some of the responsible AI principles. Then we're going to talk about AI content safety. Then we will discuss about the RAG pattern, which is the core of building the Copilot. We will go into the detail and some depth of how we and some of the best practices. We will talk about the chunking, which is part of building Copilot, some of the techniques, embedding, vector search, and then we will do some demo as well. Cool. Now, the journey of AI always it's not new. It's been there since long time. It's there since 1950s. And that definition, the AI, it's like a make machine intelligent so that they can think like a human, or they can maybe exceed the human thinking. That was the idea. Then the machine learning came. It is about giving the data to the machine and let the machine learn on the data. And then based on that data, they can make the predictions. Then the deep learning comes into picture. Then about 2012, which is using the artificial neural networks to make the decision and make machine more efficient in learning the model and making the decision and doing the decision making. Then the generative AI come in 2021. That was the evolution of the AI. We all know that. What this entails is this is about generating the contents. That's why it's called generative AI. It is about new written, visual, auditory contents, and now there's a further evolution, which is now the building the videos, and Sora is the one which is being released very recently. This another level, not just text, then images. Now you can build the video as well. You can just give the text prompt and will build a very nice 4K video or 8K video for you. All right, so Microsoft itself, the Microsoft platform itself is built on the AI. So when we talk about the application stack, the Microsoft 365, which is the suite of the Office tools and products, Windows, they all built on top of the AI. Dynamics and other stuff. Plus the platform, application platform like Power BI, Power Apps, Power Automate, and some other, they are also leveraging the AI now. Some of the scenario-based tools as well, like cognitive search, document intelligence, and some other. All of these are built on top of the customized model, which is the vision, speech, language, decision making. And now there comes the OpenAI, Azure OpenAI Service as well. And they all build on the foundation of Azure machine learning. So as you can see, Microsoft stack is all using the AI. And you can see that there's a lot of AI Copilot coming in, getting released very day by day. For example, Copilot 365, Office in the 360, which is embedded on Office 365, plus GitHub Copilot and some other. So when we talk about this, so this is the collaboration that OpenAI, that was a separate entity, then that was collaboration with Microsoft, The motto of OpenAI was that ensure that artificial intelligence benefit humanity, and Microsoft is every person and organization onto the planet to achieve more. So that's a collaboration. In order to achieve four things. First is build tools and technologies. That means that build a new models and platforms and technology and other stuff. Plus, do the research in the form of in the AI, which is I just said the Sora is the new one which is coming, right? GPT-4 plus vision model, these things like that. The evolution is coming, and more new research is happening. So this is a collaboration with both entities. Plus, making AI available for everyone, giving the platform as a tool and tools and platform. So that's the purpose of that. Plus, you can see that this happened. The collaboration happened about OpenAI service was launched around this date, and some of the latest models are available. So some of the models, for example, large language model like a GPT-4 Turbo and 3.5, GPT-4 plus Vision. So this is about taking image as an input, as a prompt, as an input, and do the stuff in there. So this is their latest release plus fine-tuning, DALL-E 3. This is for the image generation. I didn't put Sora because that's not been released, but that's going to be coming. Plus the Whisper for transcription and translation. And at the bottom of that, you use your own data, AI Studio, and assisted APIs to build the stuff on top of that. Now, what is the OpenAI service? So this is there are two parts of it. First is that these are a generative text models which are there. GPT-4, GPT-4 Turbo, 3.5 Turbo, and the new GPT-4 for Vision, which I just said that taking the images as an input. It's called GPT-4 plus Vision, and the DALL-E for image generation. At the bottom of it, you deploy your own data. You bring your own data to leverage the AI platform. You can use the provision throughput unit, which is called PPTU, just giving you the guaranteed throughput, plus assisted and functional plugin. So this is all it's a bunch of it's all comprises of the Azure API service, OpenAI services. Now this is very important when we talk about the AI, and when we talk about using the Azure OpenAI, we think about what's going to happen with my data, because all we are dealing with is with the data. So the important thing is that your data is your data. Microsoft is not using your data. Your data is your data. That means it's not available to other customer. So first of all, what data you provide. So your data you provide in the form of the prompts, which is input, and the output is the completion. When you call the completion API, which is Azure OpenAI, when you call the API, it is the output, plus the training data you provide. If you are fine-tuning the model, you provide the training data. That data is your data. So it's not available to other customer, are not available to the OpenAI. So OpenAI entity, the separate, they don't have access to your data, and they are not used to improve the OpenAI models at all. Are not used to improve any of the Microsoft or third-party product. And also, if you use the fine-tuning, use your data for fine-tuning the model, that fine-tuned model stays with you. That fine-tuned model will not be available for the other customer. So that is the important consideration. So if you are using the Azure OpenAI, you choose the model, you choose your data to fine-tune that model stays with you. That would not be available for the other customer. And the important thing is that the Azure OpenAI is not running on the OpenAI like an open source or the third-party one. It is running on Azure stack. So when we say Azure OpenAI, it is running on Azure infrastructure, not on the OpenAI, which you can see ChatGPT or OpenAI API. So it does not call. So if you are calling the Azure API, it does not call at the back end the OpenAI API's API. It does not call that, because it stays within the Azure infrastructure. If you are calling OpenAI, it will stay within the Azure. So that's important thing to consider.
Stay in the same region.
It stays in the same region as well. Correct. All right. So let's move on. When we talk about the API, it's kind of great power comes with the great responsibility. AI gives you the power. Now it is using it responsibly, using the power responsibly. So these are the Microsoft 6 of the principle that called responsible AI principle that Microsoft came up with. And Microsoft use this principle, adopt this principle, and in every of the AI work. For example, fairness. Fairness is the model should be, the AI services should be available regardless of the region, demography. It should be available to all people. It's a fairness. Reliable and safety, of course, should be reliable. The AI services should be reliably available. Plus safety, secure, it should be securely available. Privacy, of course, it's a data privacy, which we just saw in the previous one, that we talk about the data. So data stays, your data is your data, it's your privacy. Inclusiveness means include all the genders, all the religious background or ethnic background, include all. There should not be biasness, and accountability, like all the people using the AI should be accountable of using it. And the transparency, of course. In order to embrace these principles, we need some sort of framework, something to do, to adopt these ones. So to do that, you need to have some sort of governance in place. If you are adopting these principles in your organization, you need to have some sort of governance in place to adopt these principles. Plus the rules. So rules means that you need to have some sort of rules to standardize the requirement, AI requirement, within your organization. Plus training and practice, some sort of training within your organization, some sort of best practices for AI. It means that the developers should be following those practices. Plus tool and processes within the organization. Some approved tool, of course, if you are working in a financial industry, you know that all the tools have to be approved. Plus some payment industry and some other, of course, that the tools have to be approved. Developer cannot just pick and choose the tool. It has to be approved tool. And the processes, of course, in order to adopt and deploy. The processes means, all the, for example, if you're deploying the model, you need to have a predefined model to deploy the model, use the CI/CD pipeline, use the DevSecOps processes, all sort of thing. Now, the other stuff is, which is very important, when we talk about the responsible, we responsible AI principle. How about some of the harmful content? Of course, we would not allow, if we have the OpenAI model, we would not allow some sort of hate kind of content, because this is, so when we talk about the generative AI, it is about generating the content. You give the user inputs, which is the prompt, and you get the output. But you would not want in the input and the output any kind of hate or sexual or self-harm or violence. So Microsoft provides the AI content safety. The way it works is that you define, these are the 4 categories, and then you rate against scale of 4 or scale of 8, the severity level you define, and it will assess your content input based on the severity level, and then user can take action. So you can define the UI that what action you want to take. When you go to the, I will show you in a moment. So when you go and create the model, and then you can go to the content safety, and then you can define these four categories, and you can define these levels as well. So let's say if you define this, okay, for example, up to level 2, you're saying, okay, it is auto allowed, for example, and up to level maybe 4 and 6, you can say auto reject, or you can say for certain level, it should go to the human moderator or someone who should go and look at and approve it, something like that. This is how it will work. So this just flow that how it will work. So you have a customer application, your application, you interact with the Azure OpenAI endpoint. That endpoint has the filter RAI, responsible AI filters, and then that interact with the backend responsible AI assemble, and that assess your hate, sexual, text, or images, and it will do the content filter. If it is all okay, it will return the reply. Otherwise, it will prompt you like abuse concern or something. So what this is showing is that from your application side, all you are doing is you're calling the endpoint, and when you do and select the model, you at the model level, when you do the deployment, there you will do the content filter or those settings, and then the backend will go and check if the content or the prompt that they just coming the user question is not harmful against these category. And if it is not, then it will allow you to do it. It's very simple. Okay, now let's talk about the Copilot. So Copilot is about everywhere now, about every Microsoft stack. As I said, it is in the 365 Copilot, so it is being embedded into the Office. That means that if you're writing the, let's say, using the Excel, then in the Excel you have a data, you can tell the data do this stuff, for example, do the analysis, you can do very good financial analysis, just using the Copilot. You can say that, hey Copilot, this is my data. What will be you can do the projection, like, for example, this is my sale data and how it will look like next 2 years, something like that. Similarly, for the PowerPoint, you can just open the new PowerPoint, new file, and go to the Copilot and say, okay, I want to create the PowerPoint for XYZ, presentation for XYZ. It will go and create for you with the nice photos and every stuff. And same for the Outlook. You can craft very nice emails. If you receive the customer email, for example, then you can ask Copilot just reply to this email, and it will craft a nice email. And this is very good for the people who work in a support, because sometimes you get very annoyed customers' email, and you want to reply them very nicely, and you can use Copilot to do that. I use that actually; it's very effective. And for Microsoft Dynamics, is there Power Platform? This is really handy stuff. So Power Platform is a low code and no code framework of Microsoft. Now it's one step further. You, instead of going to the UI and do the stuff, you can say for the Power Platform, hey, just build a form for me, and the form would have this XYZ field, and it will build a form for you, for example. It's very easy. Similarly, Copilot for security, Windows Copilot is there. With Windows 11, it's going to do a lot of your Windows admin stuff. Plus GitHub Copilot. So developer would love it. I don't know how many people, anybody used GitHub Copilot so far? You're using here, 2 people, not many, 3. So I would say that this is really handy tool. I being developer, I like it a lot, because not only I can write the code using it, I can say, okay, for example, I just need to write just an example, the function who will return me prime number, for example. I just go to the Copilot and say that write the function who will return the prime number. It will return me that. Similarly, if I am looking at some code which is written by some other developer, I can highlight the code and ask Copilot what this code is doing. It will save me a lot of time, because otherwise I have to go and understand the code. The Copilot will go and tell me what this code is doing. Similarly, I can use it for code reviews. I can use it for unit testing. I can ask Copilot, this is my code. Copilot go and generate the unit test for this code. And that saves my hours of work. So this increases the developer productivity. And one of the case study was one of the big banks recently. They published online as well. They did the case study, and they find out that they did it silently within their developer community, and they find out that bring about 40% of developer efficiency when they use the Copilot compared to just writing the code and doing the stuff. So that's the big efficiency, of course. In terms of developer efficiency and velocity improvement, that brings a lot.
Using 40 GPT-4, so it's much better.
It is, yeah, definitely, yeah. Okay, so now let's move on. So when we talk about building your own Copilot, so the things we saw before was the one which are there already. But if you want to build your own Copilot, so what this Copilot is doing, it is just using your data and calling the OpenAI endpoint and do the stuff. Just I'm very simplifying it, So this is what it is. See, this is your application. We call it Copilot agent. Then it is calling the OpenAI endpoint. That endpoint is using your data. So it could either be your own data source in the form of file, URL, database, storage, or anything, or you can integrate it with a third-party data source. And it will work on your own data to give you the result. I will give you the example in a moment, but this is how it is, very simply in a simplified form. So some of the use cases, very common use cases of using or building your own Copilot within your own organization. It's like a B2C. Almost every customer-facing website has a chatbot, right? We saw that. But what this chatbot is built on? It's built on FAQs, It's a pre-built knowledge base it is built on. But it's not smart enough to go and understand the user intent and return the result based on the, return intelligently. So what you can do is you can integrate your chatbot with your company knowledge base, with your whole company knowledge base, so that it can, of course, not whole thing, whatever the customer facing, and then it will return you the response based on the user intent. Similarly, employee chatbot. You can create the chatbot for the internal employees so that they can look at the internal knowledge base. I remember the time when I used to code long time ago. Then if I need to find if some other developer did something, it took me a lot of time because I have to go to the Confluence, do the search, or talk to the people or other team if anybody have done the similar stuff, or sometimes like a support guys, the people who are in the customer support, and if they have a support ticket, sometimes they want to see if there's a similar issue, and because that makes it very easy for them if the issue happened before, and then they can see the fix so that they could quickly return response to the customer. In that case, this is very helpful because you can integrate with the knowledge base. You have your own knowledge base in the form of Confluence or database or somewhere, and then you can have an employee chatbot, or it will go and just you search, enter your problem or whatever the customer's issue is, it will go and give you the solution. It's very handy. Similarly, other use case product and facility documentation, agent assist, you can see a lot of their use cases. I'm not going into detail of each of that, but this just gives you the idea that how many. It's a lot of use cases that we can use, but it's not limited to this. You're not limited to this because if you have the idea that you can build on your own data, then there's hundreds of use cases you can come up with. All right. So how we're going to build it? We have been just talking about the theory so far, but how we build it. What is the framework, So at the bottom of it is the AI infrastructure. That's the foundation. You need to have the foundation infrastructure. So that is provided by the Microsoft AI infrastructure, where your model are running, your data being analyzed, those sort of things. That's the AI infrastructure. Then the foundation models, you don't have to develop on your own model unless you want to fine tune your model for your specific need or specific vocabulary need or specific context. But the foundation models are available. Then you're going to use those ones. Then you use data grounding is your own data. I will come into that moment in a moment. That you bring your own data, ground it, and then you will use the meta prompts and the prompt flow, which is prompt flow is just a kind of orchestration that you use, and then you build Copilot apps on top of that. So on the right side, you can see that this is all stacked by the Azure OpenAI Service, and all of this is backed by the built-in safety and responsible AI tools. So this is the framework of building your own Copilot. So let's talk about the RAG pattern. So this is the, I would say, core of the building your own Copilot. Retrieval Augmented Generation. 3 parts of it. Retrieval Augmented Generation. So when I say your data, you store your data somewhere, you retrieve your data. So when your user question comes, which is first part, you retrieve your data from where the data store is. You retrieve your data based on the user question. You retrieve your data, add your data to the prompt, which is the augmentation. So augment your data with the user question, and then pass that data, which is a query model, to the large language model. And then large language model will return we see that, okay, this is the data, this is the user question, it build the response and return the result back to the user. Very simple. So retrieval, augmentation, and generation. So retrieval is again getting the data from your data wherever data is saved. Augment your data to the user question or prompt, and then generation, call the large language model that will generate the response and you send it back to the user. Very simple. So this is how it look like. Keep the previous one diagram in the mind. So this is the prompt. You're saying, so you tell the system or the model what you are supposed to do. So you're saying, okay, you are the intelligent assistant. You need to answer the question to the employee about the healthcare plan using the data that I am providing you. So you need to tell the model that I am providing you the data, answer the customer question based on the data I provide you in the simple form. You pass the question. This is the question, does my healthcare plan cover annual eye exam? This is the question, that user question. And you pass the source as well. You tell, because this is what I get. So this is retrieval part. I retrieve the document based on the user question and pass the question and the source and the prompt to the model. And then model will analyze this and return the response. You see the response? What it is saying is, based on the data provided, it covers your eye exam is covered under the plan. So this is not the normal search. I mean, if I'm thinking, okay, I can implement this as a normal search, but how about the user intent? User is asking this. If I'm doing the keyword search, it's going to be very difficult, because if I'm doing the keyword search, we'll go and search the keyword. I may get some response, but it may not be kind of relevant to the user. Or what if user change the language here? This is kind of looking similar, because I can say, okay, health cover plan, annual eye exam. These are the words. Okay, I can go and search this keyword into my document store, and then it will return me the response. But how about user change this language? Because when we talk about the AI, generative AI, we are talking, human is talking, and it's kind of human is returning the response. For example, if I am talking to you and ask you the question in a different variation, but you as a human will understand that. But if I'm doing the keyword search, that makes it very difficult, because the keyword means that each word should be matched. So
can I just ask, just to check, just to understand, it's still using, oh, sorry. Oh, thanks. No, I just want to check. So we are using our own data, but the model it's using is based on OpenAI, right?
correct.
Okay. So it doesn't need to learn from our data. There's no learning process from our data, right?
As long as you're using the standard or foundation model, there's no learning. But if you want to fine-tune the model based on the specific vocabulary of your organization, or you want to learn the model based on a specific context, then in that case, you fine-tune the model and use that model. Tell the OpenAI to use that particular model. Right?
But you're not using knowledge graphs here. So basically, the responses are trivial. They're often hallucinating. So you need the context to go beyond that. You need the context of knowledge, business, to actually help. You get a lot of hallucination.
Yeah, I will cover that part. Yeah, I'm covering it then. Exactly. This is a good question. Okay. So if we understood last two slides, then let's move on to the next one. When we talk about the RAG, so retrieval, augment, and generation, retrieval is very important, because it needs to extract the data based on the user question and intent. As I said, keyword may not work. So I have, for example, I have thousands of PDFs, right? I store those PDF dump into my company database, let's say, any database I use. And if I just pass that question, I may not get the result, because if I do the keyword search, first of all, it will take ages to search each of that. And It may return thousands of text, and words. And when I send to the OpenAI, it will not return me the proper response. So that is why the retrieval is very, very important. Retriever part. So in order to retrieve, there are services available. For example, Azure Cognitive Search. It is available. It works on a vector search capability. We will cover that in a vector search. That's why I keep saying that the keyword search may not be appropriate. That's why it's vector search capabilities. It provides a hybrid search, advanced filtering, document security, re-ranking, and some chunking and vectorization, and much more. So retrieval part is important. So we need to see what is there, what is important in the retrieval part. So the way it works end to end is, so you have your application. You can say this is your Copilot application, right? This is your UX, the front end, where user will go and type the question. You can have a back end. Either you need an orchestrator. That orchestrator you can implement into the separate backend layer, or you can embed into here. Up to your design, how you want to design your application. So I'm just showing for simplicity that you have a UX, you have a backend layer, which is the orchestrator. So when the user enters his question, the first thing we do is we call the cognitive search, and then that cognitive search will go and retrieve me the documents, which is the retriever part. Then I combine that knowledge response with the prompt and send to the OpenAI. That will return me the response. Now this part is very important, this right side. So this is my data store. Actually, I should cover this in the next slide so that this will be more clear. What this is showing, there are two parts of it. First is the information storing. Second is the information retrieval. There are two parts of it. Information storing, this is my document library. I have my PDFs, company like a Word documents, or in the form of email, those kind of document source I have. I use the form recognizer so that I can extract the information from the file, from the document. For example, if I have a PDF document, I would use the form recognizer so that I can extract the text from the document. Then I would use a technique called chunking. So there's a limitation for the OpenAI model that there's a limitation of passing the document on the document size. So we use the technique called chunking. We chunk the documents into the smaller. Then we call the OpenAI service embedding model. So we use the technique called embedding. I will go into more detail of the embedding. So what we do is actually numerical representation of the text. So it calls like an embedding and model, and then it will, for each of the chunk, you will get the embedding, and we will store that embedding into the vector database. That is one part of it. So rather than saving the text, rather than saving the keywords, what I'm saving here is embedding of those documents, which is the numerical representation of the text. On the right side, this is my application, the Copilot application. When the user enters the search term or any query, I would call the embedding model again to get the embedding of that question. Then I will pass that to the vector database, and that will search based on that embedding and return me the response. So embedding is, I will cover that, but just keep this diagram in mind. And once it returns me the relevant information, then this side I will then combine that information with the prompt, as we saw in the previous two slides. I would combine with the prompt, call the OpenAI model. In this case, I'm calling text energy, and it will return me the response and send this response back to the user. Very simple. So two part, as I said. First is the information storing part. In the information storing part, I need to do two things. First, I need to chunk the document into the smaller documents. I need to get the embedding of those documents by calling the OpenAI model, embedding model. and then I need to store that embedding into the vector database. One part that is done. Second part is about the information retrieval. When the user enter the search query, I need to again call the embedding model to get the embedding of that query, and then pass that query to the vector database to get the relevant knowledge base from the vector database based on that embedding, and then return that to the application, and then application will combine the knowledge plus the user prompt, pass to the OpenAI model, and return the response to the user. That's how the whole Copilot thing works. Now let's talk about the chunking. So as I said, single document is too long for the model context window. If you have a big document, it may be, for example, hundreds of pages. The embedding you can't do the embedding for the whole document. You have to chunk it. There's a size limitation. So different techniques of chunking. One of the technique is you can chunk per page. For example, if you have 100 page, so you can have 100 chunks. That's one technique. Or you can do fixed size. You can just say, okay, for example, 1,000 word chunk 1, 1,000 word chunk 2, 1,000 word chunk 3, something like that, fixed size. Or you can do like a more structured, in which you can say that, okay, I know my document, I have like a sections in my document. So for each of the section, I would want to do the chunking. So this is in your control how you want to do the chunking. But the thing here is, if I do the chunking, would that be relevant for me? At this stage, no, it will not be, because what I have done so far is, I just broken that document into the smaller documents, smaller chunks, but that is still the text. It's still the text. There's no embedding so far of that document. So if I go and store the document, it won't be helpful for me, because I can't just pass that whole document to the my OpenAI and expect the result. It won't happen. So I need to do a thing called embedding. So before I do that, I touch base on keyword search. So let's say I have a keyword called access key. And if I break this down into access and key, the two keyword, but it would not be related to the user secret. So user secret is another intent, right? Access key or user secret. I know as a human, I understand that the access key and the user secret is the same thing, but if I do the keyword search, the system will not understand, because if keyword search means that access and keys are two different words, and it will never ever go and find the keyword user secret. So I need to have some sort of technique to tell the system that access key and user secrets are the same thing. How would I do it? Before I do that, just again another example here, just to understand that. For example, I have a word green. So this is like a kind of vector space of that. So you can see that these words are more closely related to the semantic meaning of this. So what we call this is semantic meaning. So access key and what was the other one? User secret. Their semantically meaning is same, right? So if I put that into this here, so for example, green here, so the more closer the point is, the more semantically close and semantically meaningful, or more close to the word, to the meaning. For example, here, green and white, green, let's say greens live, as you go further from it, you will lose the semantic meaning. So what we're saying is, when we do the embedding, we do the vector search. So the embedding, actually we will cover that, but just keep in mind that when we do the embedding, we do the vector search, and vector search is the closer the vectors. These points we can call the embeddings, numeric representation, and the more close the points are, the more semantic meaning they will be. So the way it will work is, when we do the vector search, and then if you remember the diagram in which we were passing the user question, getting the embedding of it, we were doing the vector search of it. So what I was doing is, like I said, if the user passed green, then I would get the embedding of that green and pass to the vector search, and vector search will see that for that green, what are the closer vector spaces for that, and it will return me that. This is how it works. So again, as a touch base, embedding is a spatial format of data representation that can be understood by the machine. Is a vector of floating point numbers, and the distance between embedding a vector space is correlated with the semantic similarity between the input and original format. So that means that if there are two words, for example, ice and snow, so their semantic meaning are same, so they will be in the vector space, they will be closer. So if I pass the word ice and to the vector database, it will also return me the snow, because they are semantically close into the vector space. So, for example, this is the good example. Here there are three sentences here. The neutron stars collapse core of the massive super giant, and there's another one close to the meaning, the other one. These are the vector representation of that called embedding. So in that system, events get stored, so system will know that intent of these are same, and these will be semantically close to each other. So when I search this, it will mean the same for the system. This is how it will work at the back end. There are different models of embedding. This is called similarity embedding. That's good for capturing the semantic similarity between two or more pieces of text. This is what we generally use in the Copilot. There's a text search embedding. This is for the long document. And there's a code search embedding, which I touch base on GitHub Copilot. So GitHub Copilot use code search embedding because it will suggest you the code snippet. Or if you highlight the code snippet and ask Copilot, GitHub Copilot, what this code is doing, so it will do the embedding of that code first, which you highlighted, and just go and find in its database, which is the syntactically close to that, and then return the response. Okay, so this is how it gets represented, as I said before. So user input, you get the embedding, and it will see what are the semantic, these are the vector spaces, and the more close the vectors are, the more semantically meaningful they are. So it will look things like that, and then it will return you the response. With our access key example, like if I call the embedding model, it will return me, these are the floating point numbers, which are the vector, which are the like embedding. And the way it will work, let's say with our, again, access key example as user secret example. So if I have if access key is a user input, the embedding of user secret and embedding of monkey. So it will go and cosine similarity of this with the user secret, because this is, it will go and do the cosine similarity. This is too far from the vector space. So this is too close to the vector space, so it will find similarity of access key and user secret. Similarly, with our document chunking example, I have these three chunks. I do the embedding of these, and when I have a user input, first I would go and get the embedding of it, and then it will go to the cosine similarity. It will find, say, for this document, this has the more cosine similarity than the other one. So it will go and get this document and return the response. Okay, scalability. Okay, some of the challenges. I have 2 more slides, and then I will jump to the demo. Make sure that I've not bored you so far. Okay, similarity in vector search, scalability. So some of the challenges, first the data volume. So of course, like when we talk about the knowledge base, and when we get the embedding, you're gonna end up with a huge volume of data. So this is one of the challenge. You need to have a challenge with the storage, deal with the challenge of storage capacity and management, indexing and search performance, plus query load, distributed infrastructure. Of course, you need to have some sort of distributed infrastructure wherever you store your database, whichever database you use, then it has to be on the distributed infrastructure, and the cost efficiency as well. So these are some of the factors that needs to be taken into account. When we talk about the vector search, it's a vector indexing is a challenge. About the scaling. Some of the database which support vector search, Azure Cosmos DB Mongo V4 that support that, plus Azure Postgres and Redis database. It supports the vector database. AI search has a semantic search, vector search, and hybrid search. So most commonly is AI search. It supports that, as I showed you in one of the slides, that it supports chunking, vectorization, embedding, all sort of thing. It supports that. And some of the challenges when we do the chunking, the things we need to consider: text pre-processing. So when we have a big document, we need to consider the pre-processing of the text, which is the tokenization, lowercase and normalization, stop word removal, stemming and lemmatization, similar document splitting, which is chunking, some of the techniques we need to use for chunking, overlapping, model compatibility. We need to see that the model which you are using should be compatible as well. It should cover the vocabulary coverage. If it does not, then you may need to fine-tune your own model. And evaluation, iteration, continuously improving and processing. So it is about that, continuously improving the model, continuously improving the data. If you need to load more models, then need to continuously improve and evaluate as well. And again, some other challenges: embedding quality, dimensionality, indexing and storage, embedding updates, and this one we covered already. So these are some of the challenges. I'm not going to detail of each of that, but these are just give you the idea that these are some of the challenges that you need to face when you're talking about the embedding and chunking. Okay, so let me do the demo. Hopefully you are not bored so far. I know this is a very dry topic. Yes, seriously. So what I'm going to show you, I have built a demo from the existing repo. This existing GitHub. This is a very good repo. You can take a photo of it. You can use it. This is the OpenAI demo, Azure Search OpenAI demo. What this is doing, I have a UX layer, which is my Copilot. I have like app server orchestrator. This is part of my code, this part. I have stored my data into the PDFs and docs into the data called storage account. And I'm using the Azure AI Search. So first part, I'm loading this data into the AI Search using the technique which I just talked about, embedding and chunking. Also chunking and embedding. First we do chunking, then embedding. And then I call Azure OpenAI. And this orchestrator will go and query this search and then get the data. And then after that, it will combine that and send it to Azure OpenAI. So, I'll just show you in action. For example,
It's very costly.
cost?
It was cost you. It's for the free to do, or
It depends how you use the service for the costing.
just sample.
My sample, yeah. This one I was incurring about $8 something per day for my demo. Yeah. So this is the application that sorry, it's not. Oh, sure. So this is the application that I have. I will show you the code in a moment. So here I am asking what is included in my health plan, which is not any standard. So I already loaded my data. I will show you in a moment in the portal that how it looks like. So I already chunked the data, get the embedding of that, stored into the Azure Search. And if I ask this question, now it will go and do the same thing. It will go and do the embedding of this question. Then it will go and search into the Azure Search, combine the prompt and data, and call the OpenAI endpoint.
These presets, you develop it or they are suggested by the Copilot?
The repo?
The three presets which were coming, the questions,
Or they just to facilitate, rather me typing.
you coded it, right?
Yes. Yeah. I can type the same question, the same thing. Because what you see here, when I click it, actually it put in a prompt actually. I can type, it will do the same thing. So you see that this is the response which I get. So I'm asking, my question is that what is included in my health plan, which is not in the standard, kind of tricky as well, And you can see that I'm asking what is in the plan, which is not in the standard. So what is this returning me? This is the response it is returning me. And it is also giving me the reference of that, because I'm asking it to give the reference. I will show you in a moment in the code. So this is giving me the reference of the document. Hopefully this will open up. Yeah. So this is giving me the document as well, that where it searched. So as I said, I have the multiple documents stored, and I asked to give me a citation of that document. So when I click that, because if user may want to look at the whole document or the PDS, so I ask this question, and this link, when I click, it opens up this PDF document, and it has all the details. So at the code at the back end, I show you the code quickly. Okay, so this code, this TypeScript, the front end was of this TypeScript, API.ts TypeScript, and here this ask API. So what I'm doing here is I'm calling the ask API and passing the user input to this. Then this is my backend. This is my ask API. And what this is doing is it is calling this approach. When I open this approach here, it is doing few things. First, it is okay. Here it is the this is the system prompt. As we saw in the example, you're saying that you are assistant, intelligent assistant, and give me the information from the data I provided. And I give him the example as well, that if the question comes like that, return me the response like that, and do the citation as well. This is my prompt. Then here I'm doing the search here of the user. I'm doing the search onto the Azure Search, that AI search, and that will give me the document. So I'll do the embedding first and then calling the search, and that will give me the document, which is the knowledge base, and then I pass that. I combine all of that user question, assistant, and the knowledge base, which is this question, and user content and the question, and I'm passing it to endpoint, which is calling this, and here I'm calling this endpoint, Azure OpenAI endpoint, chat completion. Where is that? Just somewhere here. Sorry, I'm just copying this. Yeah. This is building ones. Yeah. Yeah, this is just a helper function creating the embedding, but here I'm calling the completion API here. So this is calling the Azure OpenAI on this line and calling the completion API. So at the back end, Azure OpenAI is nothing but just the API, bunch of APIs. We know that. So it's just calling the API. And what it is doing, if I go back to my presentation, put in a So what this is doing is, again, as we saw before, it's taking my user input, doing a search on AI Azure Search, and just using the vector search or the keyword search. You can do the combination of both. Most of the time it does the vector search and get the knowledge base, and then it is passing to the large language model and return the response. And as we saw before, there are two parts of it. The first part is loading the document. So I'm using here Azure Storage. I've uploaded all my PDF to the Azure Storage. I use the form recognizer. Then I use the Azure OpenAI, the embedding model, and storing into the cognitive search. That all data into the cognitive search. I'll show you in a moment. So this is my document loading part, and the part which I am using my UI is that I have the app service running, and then it's calling the cognitive search. Again, just passing the user input and getting the embedding and getting the data from this cognitive search, and it's calling the Azure OpenAI endpoint and also using the Azure storage account. So I show you in the portal. So when I deployed this, it created these resources. So let's look at this search service. It used to be called cognitive search, but now it's called search service, got renamed. So when I go to the indexes, actually before I go there, I show you where my files are. So I go to the storage account. And my content is stored here. This is my content, but this is my storage account. So it's not reading here, but I load it here first, and then I load it and call the Azure OpenAIs to get the embedding and then store into the cognitive search. So these are my files, and then into the search service, I have these indexes. I just show you this to query all. So you see that this is how the documents is stored. You see all embeddings are stored. No text is stored here. All the embeddings are stored into the Azure search. All the embeddings are stored. It's a big document, a lot of data there. And this is my app service. I'm running this. I deployed my application into this app service. And this is the application I'm running out of this, not this one. This is the application I'm running out of this app service. It's a very simple application. And this is the repo that I was talking about. If you want to try it out, it's very easy. What you can do is some instruction here. You can spin up the GitHub code spaces and then just follow the instructions here. Right at the bottom, and it will spin up the resources and deploy the application for you. This is the good start, by the way, because it gives you the code, as I just showed you, and then you can use that code to build up on top of that. You can customize the UI, and of course, this is not the production-ready code. This is just for the POC. The production-ready code means that you have to look at all the aspect of security and other stuff, because at the end of the day, when we talk about the OpenAI, it's just calling the API. It's just a bloody API. It is calling, nothing more than that. So that means that all the secure coding practices, we need to follow everything. All the organization, good coding practices and deploying and all sort of stuff. Just showing you quickly out of the interest. That is one way to do it. But there's a thing called Chat Playground that you can build some POC very quickly, following the rack pattern. I'll show you quickly. I go to, let me open up my, so if you have OpenAI service, you can sign up for that. So you go to the OpenAI, and I just show you the step that how you can quickly build up your Copilot using the rack pattern. So you go to the OpenAI, and then go to OpenAI Studio. Here you go to the deployment, create a new deployment. Let's say I select a model 3.5 turbo. I select a version. Let's say no, actually select 125. Oh, no quota. Okay. Wow. Okay. And I say deployment name is demo. And advanced option, actually not here. Content filter, I say default. Okay. And I just go and create it. I create the deployment first. After deployment is created, this is my one. So I click that and click open in playground. Okay, so it may take a while. So once you do that, where is the panel? Okay. Okay, hang on. Yeah, here. So when you after you do it, the why it is not showing here? Oh yes, here. So after you open a chat playground, you see the tab here, add your own data. You click this, add data source, and you can just select your data. Either you can upload or you can select from the. These are from the different these sources. So I actually already did that. I show you that how it looks like. So after it loaded the data, it did the chunking of that as well, and it is stored that into the Azure cognitive search already, right? So and after that, I did the similar thing here. I give him the prompt. I show you the prompt. I just go to the top. My prompt here is, I just simply say that you are intelligent assistant, answer the question using the provided data. That's what I just told him to do. And here, I ask the same question as I put in the UI. Ask the same question, what is included in my health plan, which is not in the standard plan. Sorry, this one, because before that I had an error, but now it gave me, actually not this one, because I did something wrong here. So this is my question, and it gave me this response. Pretty much close to that, but give me the response and also give me the reference of the document as well. When I click that reference, any of that, it gives me, showed me the PDF here, actually. Come on. It should show me, but I don't know why it's not working. Maybe I have not refreshed this, but it will show me the PDF at the right side. Now, I can deploy this as well. So this is on my playground. There's a button here, deploy to. When I click this, as a new web application, it will go and deploy, or you can deploy into the Copilot Studio if you are using it, or deploy as a new web app. So I deployed this as a web app, which is this one. This one. So this is the web app. It has deployed with the app service. And here I ask the same question. It returned me the reply, which is pretty close to it. When I click the PDF, it showed me this, where it is getting the information from. So two way of working. Chat Playground is very quick, just for the POC. Of course, not for the production as it. And similarly, you can use the repo. But that gives you more control on the code and how you can do the chunking and how you're storing, those kind of stuff. And what else we have?
Security Copilot to make sure it's not
Security Copilot to look.
make sure that web app is
That's good. That's a good question. So I haven't tried that, to be honest. No, Security Copilot, that is onto the Azure security stack. That's not in here. So yeah. Okay, so what have we covered so far? So we discussed the journey of AI, We discussed Azure OpenAI and responsible AI principle and content safety. We discussed the RAG pattern. We discussed about the techniques of chunking and embedding. We discussed about the vector search, and we went through the demo as well. And that's the end of my presentation. Hope you enjoyed and hope I have not bored you. Thank you. Okay. Cool.
Thank you so much, everyone, for coming, and we'll see you all next time. Bye.
This is a very dry topic, actually.